For your activator today, take a look at this scenario. Imagine that a rock is dropped from a 420-foot tower. The rock's height, y, in feet above the ground t seconds later, is modeled by the equation y equals negative 16t squared plus 140. The rock's original position and its position after each of the first 5 seconds are the points 2.5, 420, 2.5, 404, 2.5, 356, 2.5, 276, 2.5, 164, and 2.5, 20. What equation could you write to describe the x position of the rock? What equation could you write to describe the y position of the rock? Well, if you think about it, if you're trying to determine the x position, every time through here, x has a value of 2.5. The rock is not moving left and right. It's only moving vertically. So you could just say for the equation for x, just x equals 2.5. Well, what about y? Y's initial height was 420. That's where that 420 comes from. So maybe y equals 420 minus, right? Oh, look, that's 16t squared. We already have that based on time, right? The y isn't going to be based on the x in this occurrence. Y is based on time, minus 16 times time squared. All right, that's what that equation comes from. So we would have an equation for the y, and we could have an equation for the x. Today's lesson, we're going to be taking a look at this when we can separate the x and the y values based on another parameter, which we would say in this case was time.